Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about double angle and half angle formulas. All right, so I'm going to give you a bunch of double angle formulas. We're going to work through some classwork problems, and then we'll give you the half angle formulas. So double angle formula for sine of 2 times the angle. So double angle, sine 2x is equal to 2 sine x cosine x. So really you're just going to have to either memorize these or refer to a cheat sheet with the formulas. Personally, for my classes, I just allow them to use a sheet. So you can have a sheet handy while you work through the problems. So I'm going to give you an example, 2 sine, and by the way, you can either, let's say, condense 2 sine x cosine x into a double angle formula, or you can expand sine 2x is equal to 2 sine x cosine x. So in this case, I'm condensing 2 sine 10 degrees cosine 10 degrees is equal to sine 2 times 10, or sine of 20 degrees. Now, if you end up with a value for x that's a 30, 60, 90 value, 0 degrees, or some increment of 45 degrees, then I'm expecting that you're going to evaluate that trig function with that given angle measure. All right, so why don't you take care of the next 3 problems on your own using this formula. I'll come back and give you the answer. All right, so 2 sine half theta times cosine half theta is equal to sine 2 times theta over 2, which is equal to sine theta. 2 sine 15 cosine 15 is equal to sine 2 times 15 sine of 30. And now I want you to evaluate. Sine of 30 is 1/2. And then you can figure out the last problem because it's just half of the prior problem. So sine 15 cosine 15 is 1/2 sine 2 times 15, which is 1/2 sine 30, which is 1/4. Okay, moving on. Cosine, double angle formulas for cosine. There are 3 of them. Cosine squared x minus sine squared x, 1 minus 2 sine squared x, 2 cosine squared x minus 1. So here are a couple of problems. Why don't you simplify or rewrite these? And in this case, we're going to condense. All right, so first one, cosine 2 times 35 is equal to cosine 70. Second one, cosine 2 times 25 is equal to cosine 50. Again, you don't have to evaluate it. And the last one is going to be cosine 2 times pi over 12, which is cosine pi 6, which is cosine of 30 degrees, which is root 3 over 2. So that one you have to evaluate. All right, double angle formula for tangent. Just 2 tangent x over 1 minus tangent squared x. So I do the first one for you, 2 tangent 50 over 1 minus tangent squared 50 is tangent 2 times 50, which is equal to tangent of 100 degrees. Can't evaluate that without a calculator. Why don't you take care of the second and third problems? I'll come back. All right, second, 2 tangent 2 theta is equal to 2 tangent 2 theta. Tangent 2 times pi over 8 is equal to tangent pi force, which you can evaluate as 1. All right, going into half angle formulas. Half angle formula for sine is equal to plus or minus the square root of 1 minus cosine x over 2. So I give you an example here, 1 minus cosine, and again we're condensing, 1 minus cosine 80 over 2 square root of that value is going to be sine of 40. So you take care of this second and third. All right, second one is going to be sine of 50. And the last one is going to be 1 minus cosine 240 over 2 square root of that value, which you can evaluate. 1 minus 1/2, which is a value for cosine 40, over 2, which leaves us with 3/2 divided by 2 or multiplied by 1/2, which leaves us with the square root of 3/4, which is root 3 over 2. And now I'm assuming that at this point in time you already understand or can evaluate the value of sine 120 as root 3 over 2 pretty quickly. So you can verify, going through the half angle formula, verify your answer is root 3 over 2. That is the correct answer. Okay, half angle formulas for cosine, plus or minus 1 plus cosine x over 2. And again, example, square root of 1 plus cosine 80 over 2 is equal to cosine 40. So I'll let you take care of the second and third. All right, we have cosine 50, and then plus or minus 1 plus cosine 180 over 2. Cosine of 180 is going to be equal to negative 1. So 1 minus 1 is 0. 0 over 2 is 0. Square root of 0 is 0. So your answer is 0. All right, half angle formulas for tangent. You have plus or minus the square root of 1 minus cosine x over 1 plus cosine x, sine x over 1 plus cosine x, and 1 minus cosine x over sine x. So I'm going to give you an example here, sine 60 over 1 plus cosine 60. And again, it looks like we're condensing. This is equal to tangent 60 over 2, which is equal to tangent of 30, which you should be able to evaluate as root 3 over 3. And I want you to take care of the second and third. Okay, second one is tangent 90 over 2, which is tangent 45, which is equal to 1. Next one is 1 minus cosine 120 over sine 120. That's equal to tangent 120 over 2, which is equal to tangent 60, which is root 3. All right, so now we're going to kind of change gears a little bit and talk about using what you know about the double and half angle formulas in order to solve for a given angle measure based on a relationship, side length relationship. So in this case, and I'm going to go through this problem with you, and then you can do a couple of these on your own. I know that sine of theta is equal to root 3 over 2, and I know that theta is in the second quadrant, and then I want you to evaluate sine of 2 theta. All right, so this is how it works. What I'm going to do is I'm going to draw my right triangle, and I'm going to identify the values that I've just determined and figure out the ones that I don't know. In this case, it works out to be a 60-degree angle as a reference angle. But I'm going to write in my opposite side of the angle here, theta as root 3, hypotenuse is 2, and I know using the Pythagorean theorem and also what I know about 30, 60, 90 triangles, that the length of the x value is going to be 1. I know it's in the second quadrant, so I can rewrite this as cosine 2 theta, and in this case I don't need to evaluate for cosine, although I can do that if I want, but I'm just going to use the value that I have for sine as root 3 over 2. 2 sine squared theta is, I'm going to substitute for theta root 3 over 2, or sine theta root 3 over 2. So it ends up being 1 minus 2 times root 3 over 2 squared, which is 1 minus 2 times 3/4, which is 1 minus 6/4, or negative 1/2. And of course, we can verify our answer because we know that this reference angle is 60 degrees. It's in the second quadrant, so it's going to end up being 120 degrees. And we know that cosine of 120 degrees is going to end up being negative 1/2. Right, so that's how it works in this case. All right, so now I want you to go ahead and evaluate cosine of theta, where sine of 2 theta, where cosine of theta is negative 5 root 29 over 29. So I'm going to pause here and then let's review the answer. All right, so again, I'm going to draw my triangle. I know cosine theta is equal to minus 5 root 29 over 29. So my value for x is minus 5 root 29 over, or my adjacent side, over my hypotenuse, which is 29. I can evaluate for the opposite side, which is negative 2 root 29, using the Pythagorean theorem. And then I'm going to rewrite sine 2 theta as 2 using my double angle formula, 2 sine theta cosine theta, substituting negative 2 root 29 over 29 for sine theta and negative 5 root 29 over 29 for cosine theta. I end up with 2 times negative 2 root 29 over 29 times negative 5 root 29 over 29, which ends up being 20 times 29 over 29 squared, or 20 over 29. Okay, next one, you guys can evaluate on your own. I'll come back in a moment. All right, so tangent theta is equal to 4, find cosine 2 theta. This is in the third quadrant. So if it's in the third quadrant, I know x and y values have to be negative. So my opposite over adjacent is going to be negative 4 over negative 1, which is equal to 4. I'm going to evaluate cosine 2 theta. I'm going to use the double angle formula 2 cosine squared theta minus 1. Cosine theta in this case is negative 1 over root 17. So I have 2 times negative 1 over root 17 squared minus 1. Negative 1 root 17 squared ends up being 1 over 17 times 2, leaves me with 2 over 17 minus 1, which is equal to negative 15 over 17. Okay, let's try one more, and then I'll let you go. Right, sine theta is equal to negative 3 over 5 for the third quadrant. Find tangent theta over 2. Okay, I'm going to use sine theta over 1 plus cosine theta for this. I draw my triangle here. I know that sine theta is negative 3 over 5. I'm in the third quadrant. X also has to be negative. It's a 3, 4, 5 triangle. So sine theta ends up being negative 3 over 5, which we have. 1 plus cosine theta is negative 4 over 5. Now I'm just evaluating and simplifying the fraction negative 3 over 5 over 1/5, which ends up being negative 3/5 times 5, or negative 3. I think I lied here. I'm going to give you one more problem. Cosine theta is equal to 15 over 17 for the first quadrant. Find the half angle formula, using the half angle formula for tangent theta over 2. All right, so I'm going to run quickly through this again. Sine theta over 1 plus cosine theta is the function I'm going to use. I have a first quadrant angle. My right triangle is an 8, 15, 17 triangle. My value for sine theta is going to be 8 over 17. So I rewrite as 8 over 17 for 1 plus 15 over 17, which is 8 over 17 over 32 over 17. 8 over 17 times 17 over 32 leaves me with a value of 1/4. All right, that's it for this edition of Otten Math. Please come and join us when we talk about, actually we're going to evaluate more difficult trig functions and equations using half double angle formulas and what we learned previously with the Pythagorean identities in the next edition of Otten Math.